Polynomial graphs. Polynomial graphs are smooth, continuous, in other words, no breaks, and no sharp corners. These are polynomial graphs. And notice, since they're polynomials, they're continuous, they're smooth, and no sharp corners. A line is a polynomial, a parabola is a polynomial, and there's many other polynomials out there. The degree of a polynomial is the highest power on the variable. So the degree of this polynomial is 4. The degree of this polynomial is 1. Remember, there's a 1 here. The degree of this polynomial is 6. Once you have the degree of a polynomial, you get 2 more pieces of information. We're going to let the degree of the polynomial equal n. So if n was 5, degree was 5, then we would expect on the graph at most 5 x-intercepts. And we would expect at most 5 minus 1, which is 4, turning points on the graph. So once you have the degree of the polynomial, you could get 2 pieces of information. The polynomial will have at most n x-intercepts, and it will have at most n minus 1 turning points. Remember, the turning points are the valleys and the hills. They're the highs and the lows of the curve. Now, if they gave you the graph, you could analyze the graph. So instead of an equation, they give you a graph. You look at this graph. Since both ends are pointing in the same direction, they could have been pointing down, but they're pointing in the same direction. We know the equation of this polynomial is even. It's an even degree polynomial. This one belongs to an odd degree polynomial since the end behavior is in opposite directions. Let's work an example. State whether the graph could be possibly the graph of a polynomial function, a polynomial of degree 3, a polynomial of degree 4, a polynomial of degree 5. So here's our polynomial, here's the graph. And since it's smooth, continuous, and no sharp corners, A is this can possibly be the graph of a polynomial. This one's a candidate for being a polynomial. Now, let's make some observations before we answer the rest. Notice there's 1, 2, 3, 4, 5 x-intercepts, and this polynomial equation has 1, 2, 3, 4 turning points. So let's answer B. This can be a polynomial of degree 3 because the end behavior is in opposite directions. So notice, since the graph is pointing in opposite directions, this qualifies it for being an odd degree polynomial. But we would like to know if it's a degree 3, because degree 3 is odd, degree 5 is odd, degree 9 is odd. But they want to know if this is a degree 3 polynomial, can possibly be 1. So we need to move on. So it could be a degree 3 up to now because the graph shows that at the end behavior is in opposite directions. But now we have to check. So if this is a degree 3, that means n equals 3. Then there should be at most 3 x-intercepts. So let's look at the graph. 1, 2, 3, 4, 5. It has 5 x-intercepts. But if it's going to be a degree 3, it should have at most 3. So at this point, this graph cannot be a degree 3 polynomial. If we were to go on and answer the question of turning points, n equals 3, so n minus 1, which is 3 minus 1 is 2, there should be at most 2 turning points. So therefore, it's also disqualified in the turning points. This one has 1, 2, 3, 4 turning points. But our formula says it should have at the most 2 turning points. So B is no. The graph that we have here cannot be a third degree polynomial. So far, we've answered yes for A and no for B. C is no. And the reason this is no is that the question is, can this possibly be a degree 4 polynomial? But degree 4 implies that it's an even degree. And even degree polynomials should have the n behavior pointing in the same direction. But these are pointing in opposite direction, so this can't possibly be an even degree polynomial. Therefore, it cannot be a degree 4 since 4 is even. So far we have A, yes, B, no, C, no. And finally, can this be a degree 5 polynomial? In other words, n is 5. Well, it's pointing in opposite directions, so it has a chance. But we need to check the x-intercepts and the turning points. So if this is the degree 5, then there should be at most 5 x-intercepts. And if you look at the graph, 1, 2, 3, 4, 5, we have at most 5 x-intercepts. So we get a yes for checking the x-intercepts. Now let's check the turning points. The number of turning points, if this is a degree 5, would be 5 minus 1, which is 4. Therefore, there should be at most 4 turning points. 1, 2, 3, 4. So there's at most, that means no greater than 4 turning points. So D gets a yes.